Hi everyone, and welcome back to the BGP Masterclass. In the first episode, we covered the theory. Today, we move to the command line. Our goal is simple: connect our Enterprise Edge router, R1, to the ISP router, RR5, using BGP. But here is the catch. We are starting from absolute zero. My routers have no IP addresses, no passwords, and no configuration. Why? Because BGP is an application that runs on top of TCP/IP. If we don't build a solid foundation first, the BGP house will collapse. So we are going to configure everything step by step, including some crucial quality of life settings that every network engineer should know. Before we configure any IP addresses, let's make our lives easier. If you've ever typed a command and been interrupted by a log message, or mistyped a command and waited 60 seconds for a DNS timeout, you know the pain. Let's fix R1 first. We go into global configuration mode. Now, the first command you should type on any lab router. Why? By default, if I type a typo like ping, the router thinks it's a host name and tries to query a DNS server to resolve it. This locks your console for about a minute. No IP domain lookup disables this behavior. It saves you frustration. Next, let's tweak the console line itself. I will add two commands here. First, this is a lifesaver. Without this, if a log message pops up while you are typing, it messes up your line. Logging synchronous repaints your command on a new line automatically, keeping your screen clean. And finally, this disables the automatic logout. By default, the router kicks you out after 10 minutes of inactivity. Since we are learning and I might be talking for a while, I don't want to lose my session. Note, don't do this on a production router in a bank, but for a lab, it's perfect. Now, let's quickly apply the same hygiene to our ISP router, R5. Good habits should be universal. Okay, the environment is ready. Now let's talk connectivity. BGP needs layer 3. On R1, we connect to the ISP via interface Gigabit Ethernet 2. We will use the subnet 10.1.15.0/24. R1 will be .1. R5 will be .5. Let's configure R1. Notice the description. Always label your interfaces. Now, we also need a loopback interface. In BGP, the router ID is critical. It acts as the router's name. We want to hardcode this using a stable interface. Now let's jump over the cable to R5. According to our topology, the connection comes in on Gigabit Ethernet 0/2. And let's give the ISP its own identity. Now, here is a very important point. If you watched the previous videos, you know we used OSPF inside our network. But here, between R1 and R5, we are not configuring OSPF. Why? Because R1 and R5 are directly connected. They share a cable. R1 knows where 10.1.15.5 is because it is directly attached to its own interface. We call this a connected route. We do not need a routing protocol to find a neighbor who is standing right in front of us. Before we start BGP, we must pass the ping test. If I cannot ping R5, BGP will never establish. Let's try from R1. Success. This confirms that the interfaces are up. The IP addressing is correct. Layer 2 ARP has resolved. We have a solid foundation. Now, and only now, are we ready to configure BGP. We have connectivity. Now, let's configure BGP. If you are coming from the world of OSPF or eIGRP, you are used to the network command. You just enable the protocol on an interface, and the router shouts, "Hello," to everyone on the link. It dynamically discovers neighbors. BGP is different. BGP is shy. It does not shout. It does not use multicast to discover friends. In BGP, you must explicitly tell the router, "I want you to talk to this specific IP address, and I expect them to be in this specific autonomous system." If you don't define the neighbor manually, nothing happens. Let's go to R1. We are in AS 65000. The command to start the process is We are now in BGP configuration mode. First, let's define our identity. BGP needs a unique name called a router ID. By default, it tries to pick the highest IP address, but in a pro environment, we hard code it. Now, the magic command. We define the neighbor. Our target is R5 at 10.1.15.5. And the crucial part, remote as. R5 belongs to AS100. Because 100 is different from my own AS65000, the router knows this is an eBGP external session. I will hit enter now, and I want you to watch the console closely. Nothing. Absolute silence. Did we make a mistake? No. Right now, R1 is trying to open a TCP connection to R5 on port 179. But R5 is configured to ignore us. It has no BGP configuration. It's rejecting our calls. This silence is normal when only one side is configured. Let's fix the silence. Jump to R5. This router simulates the ISP, so it is in AS100. Now we point back to R1. R1 is at 10.1.1, 5.1 and belongs to AS65000. Get ready. The moment I hit enter, R5 will accept the TCP connection from R1. They will exchange open messages, negotiate capabilities, and establish the session. Here we go. There it is. Neighbor up. This is the handshake we were waiting for. The TCP session is established and BGP is running. Now, let's verify this on R1. The most important command in your BGP career is this output can be intimidating, but focus on the last column. It says state/pfxrcd. This is where beginners get confused. If you see a word here, like idle or active, the session is down. Yes, active sounds positive. But in BGP, active means I am actively searching for a neighbor, but I cannot find them. It is a failure state. What you want to see here is a number. Mine says 0. Does 0 mean it's broken? No. The column stands for prefixes received. So 0 means the session is perfectly healthy, up, but the neighbor hasn't sent me any routes yet. And that is correct. We haven't configured R5 to advertise any networks. Let's dig one level deeper. Look at the third line, established. That is the key word. If it says established, you are good. You can also see the TCP port usage here. This shows you exactly how the TCP socket is built. One side is the server, port 179. The other is the client, random high port. So, we have done it. We built the first leg of our journey. We prepared the routers with proper hygiene. We verified layer 3 connectivity with ping. And we established an eBGP session between AS65000 and AS100. Your homework for today: replicate this. Don't just watch. Open CML, wipe the configs, and type them yourself. Watch what happens if you type the wrong AS number. Watch what happens if you shut down the interface. Get comfortable with Show IP BGP Summary. In the next episode, we are going to break things intentionally. We will explore the BGP finite state machine: idle, connect, active, open sent. So you know exactly what is wrong when that neighbor up message doesn't appear. Thanks for watching, and see you in the next one.